9.5 has two really good formulas in it. And the thing that happens is people get confused by them because they're both geometric series formulas. But one is for finite geometric series, and that was the one that you did on Friday. And the formula looks a little bit overwhelming, but it really is, if you can find the numbers and put them in there, you just turn it into the calculator. That's what you do. So you definitely, if you haven't already, want to watch that. And remember that finite means it stops. So I don't know if you added it. I found some more packets. So now I can actually hold one up. I don't know if you already added it in here, but this is definitely where we're talking about series summation, and for geometric, going in this column over here, and this little bugger needs to go in there. There's two blanks, and I usually add an extra set of parentheses on the bottom. Now the reason there's two blanks is because we have a formula for finite geometric series. That's what this one is. I would even write the word finite right next to it too, so that you can remember, hey, it's different for each one of these. So that's the one for finite. It stops. They say, find the sum of the first 20. That's this. And then there's a formula, which we're going to cover today, which says, hey, even though this series goes on forever, we can actually figure out what it adds up to. Which to us doesn't make a whole lot of sense, because it's like, if it's geometric, you're multiplying by something all the time. Isn't it just going to keep getting bigger and bigger and bigger, and you can't say, hey, this is what's happening? But there is one set of numbers, if we multiply by them, that actually makes something smaller and smaller and smaller. And that's fractions between 0 and 1. So we've talked about this before. I want everybody to take their thumb and their index finger and make 1 inch, about 1 inch in front of yourself. Now I want you to multiply that by a half. So that would be down to a half an inch. Now multiply that by half again. So now we're at a quarter of an inch. A half again, 1/8, 1/16, 1/32. The fingers touching yet? Pretty close, right? And that's because it's approaching 0. So when we talk about how we can find a geometric series sum for infinite, that's the only way it's going to happen. So our R value has to be between 0 and 1. So down here, we need to learn the fancy language for that. So what happens to a geometric series when we're multiplying by a number bigger than 1? Well, it just gets bigger and bigger and bigger, and that's called diversion. We're going to say it diverges. What that means is it's getting farther and farther away from the first number that you started with. They're diverging from each other. Well, if we do that for an infinite series, that's not going to happen because the numbers keep getting bigger and bigger and bigger. But if we choose a fraction, so what happens to a geometric sequence when R is between 0 and 1, which is where those fractions are going to be, between 0 and 1, that's called converging, or we say it converges. Those we can find. That's the one I just had you do with your fingers, so you could see, hey, we're really getting down to adding basically nothing. You know, that's what we're doing. And that's what calculus is based on. In fact, in the old days, this formula used to have to wait for calculus 3 in order for students to see it. Because it was one of those concepts when you had a graphing calculator, you could show students, hey, it's getting closer and closer and closer to 0. But when there were no graphing calculators being used, it just had to wait. It's one of those things you had to wait until you were ready for it. So now, when does a geometric series converge and when does it diverge? Well, it's going to diverge when R is greater than 1. Now, we're not talking about if it's a negative number or not. We're saying the absolute value of R. So don't look at if it's negative. Look at it as Hey, they said it was 7/4. Oh, that's bigger than 1. That's going to diverge. I can't do that one. The numbers are diverging. They're getting too far apart. But they converge, which is good because that means they're coming together, getting closer to 0, when our R value is one of those fractions or decimals between 0 and 1. So is this new? Yeah, it kind of is. You can think of R just like A, and then it's not, because we always had our vertical stretches when R was greater than 1. And yes, your hands are going to diverge as you get that vertical stretch. And then it was a compression when we had A values between 0 and 1. And yeah, you can see my hands coming closer and closer together. That's how this works. So some of these, I know it's going to be hard, but you're going to have to write down no sum for today, because some of them we can't find. If they give us an R value that's greater than 1, we just have to say no sum and move on to the next problem, because they're just getting bigger. Otherwise, this is usually everybody's favorite formula from this chapter. It's super short. Look at this little bugger. So an infinite geometric series, here's the big word there. This has to be the ones with the ... at the end. Has to be infinite. An infinite geometric series with a first term of a sub 1 and a common ratio of r. And notice they're doing absolute value is less than 1. I'd really prefer they did what we did on the last page. Bless you. And just used it that way, so it's very obvious, hey, it has to be a fraction between 0 and 1. Now that actually has a finite sum. We can actually find it and count it because we're adding things that are closer and closer to 0. So an infinite geometric series with the absolute value of r greater than or equal to 1 does not have a sum. And like I said, they're going to challenge you to check, is this something we can use this formula for or not? So now this one should go on the front cover. Geometric, way down here at the bottom, should be the last little blank down here. S equals a sub 1 over 1 minus r. S equals a sub 1 over 1 minus r. Now, how do I know if that is on the formula sheet 2 days from now on the test, that this is the one for infinite geometric series? There's something missing up there. I mean, we've worked with a sub 1 and r before. What's missing is, notice there's no n here. We're not saying find the sum of the first 20, find the sum of the first 30. It's, hey, find the sum of all of them. So no more n in there. All right, so here's their first question for us. Does it converge? Does it diverge? And if it does converge, if it gets closer and closer to 0, what is the sum? Can we find it? So the first thing we want to do is take any term and divide it by the term in front of it. I think that's the easiest one there. Just taking 1/2 and dividing it by 1. Well, that's going to give you 1/2. But it doesn't matter if you use those two or if you did 1/4 divided by 1/2. When you multiply by the reciprocal, you're still going to get 1/2. So we just talked about what happens when you multiply by 1/2. It gets smaller and smaller and smaller. That's definitely converges. And this is our, hey, that means we can find it moment. So S equals, nice little short formula. What's the first term? It's a 1. It's right there. And what did we say they were multiplying by? Now, if you want to just put that in the calculator, make sure you just put parentheses around the denominator because there's more than one term down there. But you really could just say, oh, I know 1 minus 1/2 is 1/2. I'll multiply by the reciprocal. Well, look at that. It's 2. So if you add this infinite series up forever, it's going to approach that little number of 2. I'll make sure I switch the, attendance over here so I don't forget. Why don't you look at the next one? And the first thing you want to do is you want to figure out what is R in that formula. Looks very different, doesn't it? Yeah, because this is our sigma, our summation notation. And then I have to remember, oh, wait a second. These are supposed to look like a sub n equals a sub 1 times r to the n minus 1. So r is whatever's being raised to the power. So what's r? It is negative 5/4. Now here's the part we don't care about to figure out whether or not we find this. The negative doesn't matter to us at all. 5/4, is that a fraction between 0 and 1? Well, then we can't do this one. We have to say no sum, it diverges. Diverges. No sum. Depending on the directions. It probably will say something like, if it has a sum, find it. So you just write no sum and go on to the next one. But I'd be careful with that because chances are pretty good if we put one on the test, it's because we want to see you actually find the sum. There might be, like 2 or 3 of them. If that's the case, then I would expect one of them to be no sum. Alrighty, let's look at these. Does the infinite series converge or diverge? If it converges, what is the sum? Okay, give me a pair here that you would like to do the division for to find r. Sure. Starting to get some nastier fractions on the other end, so why not do this? So 3/4 times 2 over 1. You can either just do top times top, bottom times bottom, and reduce, or you can notice, hey, 2 goes into 2 once, into 4 twice. That's going to be 3/2. Does it converge? No, it diverges. And they said, what is its sum? So let's go ahead and tell them, no sum. Has to be a fraction between 0 and 1. Alrighty, let's look at B. Give me a couple of fractions you wouldn't mind doing the division for. Some of you are saying, none of them. I'd want to do them all. Use the calculator if that bothers you. Use the calculator to do the division. But, I mean, they're nicer on this end, right? 1/3 is definitely better than negative 1 over 81. So negative 1/9 divided by 1/3. Multiply by the reciprocal. Little reducing. Don't look at the negative. We don't care about that when we're starting this. Is this going to be one we can find or not? Yes, this converges because 1/3 is a fraction between 0 and 1. So this is converging. And I have my nice little formula here. S equals a sub 1 over 1 minus r. Do we know the first term? Yeah, they gave it to us. It's 1/3. And what was r again? Good, negative 1/3. We do have to use negative 1/3 in the formula. So now here's where, if fractions are kind of messing with you and scaring you, well then just put it in the calculator with all the parentheses and all will be good. So on the top we've got the 1/3, and 1 minus a negative 1/3 would be 1 plus 1/3, which is 4/3. So 1/3 times 3/4, 3's cancel out. How can that be? We're going to keep adding all those fractions together and they're only going to add to 1/4? That doesn't make any sense. Until you notice what? Every other term is negative. So we're adding, but then we're subtracting. Then we're adding, and then we're subtracting. So definitely, it's different. You want to think about whether or not you're getting the right ideas, the right answers, but you also have to remember to go back and look at it and say, what's going on here? Alrighty, C, n equals 1 to infinity of 2/3 to the n. Well, let's see. Oops, I wrote r twice. That's what it's supposed to look like. But again, r is what's being raised to a power. So what's r? 2/3. Does this one converge or diverge? It does converge. 2/3 is a fraction between 0 and 1. That means we can find it. But I need the first term. Well, to get the first term, remember, you can always take the lower limit and actually plug it in for n up here and see what you get. So if we take a 1 and put it up here, it's going to be 2/3 to the first, which is 2/3. Again, if you want to use a calculator, parentheses all over the place, but 1 minus 2/3 is 1/3. And then we can multiply by the reciprocal. And our little 3's are going to cancel. And we're going to get a big sum there of 2. 2/3 plus 4/9, and you just keep going. And yeah, they're getting smaller and smaller right away. So, D says, if you have an infinite geometric series, are your only options converge or diverge? It could be flat. If our R value is 1, we'll always get the same number back. So it is possible that you could see that case. So R equals 1 would be neither. But what we want to watch for, especially on the test, because we're not going to give you one that all adds to the exact same thing every time, is R a fraction between 0 and 1, because then it converges and we can find it. Is R a number that's bigger than 1? Well, then it diverges and we can't find it. It doesn't have a sum. That's today's formula. That's it. So this is definitely an assignment you can finish before you go. Anybody have any questions about our infinite geometric series formula? All right, let me get you this one. So you can get going on it. Again, if you're not comfortable with fractions, use the Rapid Identity app. If you don't have your own calculator, just use parentheses for everything and it'll all go fine.